You've looked at the moon your whole life, but you've never actually seen half of it. Not because clouds got in the way, not because it's too far, because that half physically cannot face you. The moon is tidally locked to Earth. Billions of years ago, our gravity pulled harder on the side of the moon closest to us, creating a slight bulge, and that bulge acted like a brake. Over millions of years, it slowed the moon spin down until it matched its orbit exactly. Now the moon rotates once for every trip it makes around us, which means one face is frozen toward Earth forever, and the other is frozen away permanently. No human being saw that hidden face until 1959, when a Soviet probe called Luna 3 swung around it and beamed back a grainy, half-blurred photograph. Humans wouldn't lay eyes on it directly until 1968, when the crew of Apollo 8 flew around the moon and became the first people in history to see it with their own eyes. What they found broke expectations completely. The near side, the one you've stared at since you were a kid, is covered in dark, smooth patches. Ancient astronomers thought they were oceans and named them Maria, Latin for seas. They're not water. They're solidified lava, flooded across nearly a third of the visible surface more than 3 billion years ago. The far side is almost none of that, less than 2%. Instead, it's crater on crater on crater. Jagged, mountainous, brutally cratered highlands stacked up for billions of years, with barely a drop of lava anywhere. Quick myth to kill right now. It is not the dark side of the moon. It gets just as much sunlight as the near side on the exact same cycle. It's dark to us, meaning hidden, not dark in daylight. Pink Floyd got the vibe right. The astronomy is wrong. Same moon, same age, same sun. Two almost unrecognizable faces. Here's the part that should really mess with you. That man in the moon face people have pointed out for thousands of years. Those eyes, that mouth, that's the Maria. That's this exact asymmetry staring back at you, and nobody knew why it existed until spacecraft started flying around the back of the moon. So what actually happened? For decades, the leading theory was simple: crust thickness. In 2011, NASA sent twin spacecraft, nicknamed Ebb and Flow by the students who named them, to fly in tight formation around the moon. As they passed over regions of different gravity, the distance between the two spacecraft stretched and shrank by fractions of a millimeter. Scientists tracked those tiny shifts to build the most precise gravity map of the moon ever made, and it revealed the far side's crust runs roughly 20 kilometers thicker than the near sides. In some spots, almost double. Thicker rock means magma from deep inside has a much harder time punching through. Thinner crust on the near side, easier eruptions, more lava, more Maria. Clean story, except it had a hole in it. The far side isn't uniformly thick everywhere. It's home to the South Pole Aitken Basin, one single impact scar 2,500 kilometers wide, among the largest craters in the entire solar system. At its center, the crust is thin. Thinner, in fact, than most of the near side. If crust thickness alone explained everything, that basin should be drowning in lava. It isn't. It's dry, cratered, and barely touched by volcanism. So thickness wasn't the full answer. Something else was happening, deeper inside the moon itself. Here's where it gets interesting. The near side runs hot. Not surface heat. Internal heat from radioactive elements like potassium, thorium, and rare earth elements, concentrated in a hidden region scientists call the Procellarum KREP terrain. That radioactive material works like a buried furnace, warming the mantle underneath the near side for billions of years. Satellite data shows that mantle runs up to 200 degrees Celsius hotter than the far sides. Hotter mantle, more melting, more magma pushing upward wherever the crust would let it through. But why was all that radioactive heat sitting under the near side in the first place and not spread evenly around the whole moon? For decades, that question stayed open. One early idea even proposed a second, smaller moon once orbited alongside ours and quietly merged into the far side at low speed, thickening it without leaving a crater. It was a clever guess. Nobody could test it. Then in 2024, everything changed. A Chinese spacecraft, Chang'e 6, did something no mission ever had. It landed inside the South Pole Aitken Basin on the far side, scooped up almost 2 kilograms of rock and soil, and flew it back to Earth. The first far side samples humans have ever physically held. What scientists found rewrote the story. The far side rock was about 2.8 billion years old, and it had crystallized from lava roughly 100 degrees cooler than near side samples of a similar age. The far side mantle held far less water than the near sides. Its chemistry looked stripped down, almost drained. Scientists call it ultra-depleted, as if something had violently stolen the ingredients volcanoes need. And that South Pole Aitken Basin itself? It was blasted open around 4.25 billion years ago by an impact that released energy equal to more than 1 trillion atomic bombs. Big enough to be one of the most violent single events in the moon's entire history. Researchers now think that impact didn't just scar the surface. It hit hard enough to disturb the moon's deep interior, possibly shoving hot, calorie-rich material toward the near side on impact, while leaving the far side mantle cold, dry, and stripped bare for the next 4 billion years. One catastrophic collision, over 4 billion years ago, may have permanently rewired the moon from the inside out, splitting one small world into 2 hemispheres that would go on to look and behave like entirely different planets. It's not just a scientific curiosity, either. That far side is now considered prime real estate. It's permanently shielded from Earth's radio noise, which makes it one of the quietest, cleanest places in the solar system to build a radio telescope. China's Chang'e 4 mission already landed there in 2019, the first ever landing on the far side, made possible only because of a relay satellite parked in space to bounce signals back to Earth. Future missions, including parts of NASA's Artemis program, are eyeing that same hidden hemisphere. The face you've stared at your whole life, the one your ancestors named seas and drew myths around, looks the way it does because of a single ancient act of violence you will never see directly, because right now, as you read this, its scar is facing away from you, and always will be. Every full moon you've ever watched rise, every photo you've ever taken of it, every wish you've ever made looking up at it, all of it, one half of the story, on permanent physical repeat. Next clear night, look up. You're only ever seeing half of it. Follow for the other half.